In this 3 steps to sketch on function transformations, we are going to take a look at a transformation on the cube root function. So we'll look at the equation y equals negative cube root of 2x minus 2. And we'll do this using our on the graph method. So here is our reminder of our equation and our 3 steps to sketch outline. And let's first start by reminding ourselves of the parent function that we are transforming. So our parent function is the cube root of x. That's our sideways snake graph. Okay, so once we've established that, let's go ahead and analyze our transformations. This is step 1. First, we'll look at our horizontal transformations. So that's found underneath the radical here, this 2x. And we know this will impact only our x's, and we'll do this like we would do a solving order. So we'll determine our transformation by just getting a helper equation, 2x set equal to 0. And we ask ourselves, what would we do to solve for x? We would divide by 2. Okay, so that tells us our horizontal transformation is a compression by a factor of 2, or we're dividing all of our x's by 2. And that's our only horizontal transformation, so we can move on to our vertical transformations. These will only affect our y coordinates, and we can see we do have multiple here, this negative, understood -1 out front, and this -2 at the back. Okay, so we do need to be conscious of the order we apply them. Remember, our vertical transformations should always be applied in PEMDAS order, so the multiplication will come before the subtraction. All right, so multiplying by a -1 indicates that we have a reflection, and that will be a vertical reflection, so over the x-axis. So we'll note that's either reflecting or just multiplying our y's times -1. And now to finish up our vertical transformations, we look at that -2, so we know our graph will be moving down 2, or our y's -2. All right, so now we've analyzed our transformations and we are ready to move on to step 2. So we'll first start by plotting our parent function, and then we'll apply the transformations by making intermediate graphs. So be sure to have your different colors, and let's go ahead and get started. So we know this cube root of x is our sideways snake. Okay, so let's plot our points that are close to the origin. So that's -1, -1, 0, 0, and 1, 1. And now let's switch to blue to create our first intermediate graph. Okay, so our horizontal transformation will be what we tackle first. All we need to do is divide our x's by 2, or you can think about this as a compression. So cut the distance of each point, the distance from the point to the y-axis, cut that distance in half. Okay, so starting with our leftmost point, if you cut that x in half, or that distance in half, you end up with a point at -1/2, -1. The point on the origin stays the same because it's on the y-axis. And then our third point, again, you cut that distance to the y-axis in half. All right, so this blue graph is our intermediate graph. We'll be working from that from now on. Okay, so we're done with our horizontal transformation. Let's switch colors and move on to our vertical transformations. Okay, so now we want to tackle our reflection over the x-axis first. We're making all the y's opposite values. So take the blue graph and you just reflect that over the x-axis. So we'll do yellow intermediate graphs. The point on the origin stays, and then we have the final point reflected. So we've taken care of that. And now let's switch to our final color. So now in red, we'll shift each of these yellow points down 2. So down 2 for each of those points. And we are done transforming, so we can move on to step 3. Darken these final points, so these red x's, these are your finished points for the graph of y equals negative cube root of 2x minus 2. And we can sketch in the graph. And it's helpful to know here that we did reflect. So looking at the parent graph, you can see that this final red graph has been reflected over the x-axis. All right, so that was how to graph a transformation of a cube root function using the on the graph method.